Hello students, today I am here with sets part 2, that is operation on sets. There are various types of operation that we can apply on sets. One of them is union of two sets. So let's find what is union of two sets. Children, it is read as A union B is defined as collection of elements of A or B, means those elements which are either present in A or B will be the part of the A union B. There may be elements which are present in both sets, but we take only once. So this can be defined as union of two sets. In mathematical terms, we can define it as X such that X belongs to A or X belongs to B. Let's solve an example. Here example is A is equal to 1, 2, 3 is a set. Another set is B 2, 4, 5. Here we have to find A union B. So we can find it by listing all elements of which are either present in A or B, 1, 2, 3, 4, 5. Now elements of A union B are either present in A or B or in both. So this is the way to find A union B. Now we shall move to our next leg, that is intersection of two sets. What is the intersection of two sets? It is the collection of all common elements of A and B. Means those elements which are present in both A as well as B are said to be the part of the intersection of A and B. Means common collection of all common elements of A and B. Mathematically we can define it as A intersection B is equal to X such that X belongs to A and X belongs to B. Means X must be the element of A as well as B. Now take an example. Here example is A is equal to 1, 2, 3, B is equal to 3, 4, 5. Here you can observe that 2 is the only element which is present in both sets. It is present in A as well as in B. So A intersection B will be, there are two elements 2 and 3 which are present in A as well as in B. So here A intersection B will be 2, 3. So this is the intersection of two sets. Now children, move to disjoint sets. What are disjoint sets? If intersection of two sets is phi, means an empty set, or in other words we can say that they do not have any common element, then we say that these sets are disjoint. Now children, move to some basic laws of operation on sets. There are certain basic laws, you must know them, and Here they are written one by one. You may take a screenshot of this page so that you could write in your notebook and memorize these basic laws. They are very simple to memorize. A union A is equal to A means union of a set with itself will always be set itself, and same happens with the intersection. Now A union phi is equal to A intersection union is equal to A union universal set is equal to universal set. This is property fifth. A intersection phi is equal to phi, because A has certain elements but phi does not have any element, so there will be no element in common, so A intersection phi will be phi. Now move to property seventh. A union B is equal to B union A. Actually this is property of commutative under operation union. So A union B will be same as B union A. And now same happens with the intersection property. This is associative property. This is associative on intersection. This is distributive property. A union B intersection C is equal to A union B intersection A union C, and this is distribution over intersection. Now if A is subset of B, then it is implies and is implied by means A union B is equal to A, means A union B is equal to A, then it will imply that A is subset of B, and if A is subset of B, then it will imply A intersection B is equal to A. If IFF means if and only if, it means if and only if, means if we write X if and only if Y, then it means X implies Y and Y implies X, means it will be true in both sides. Means if X is there, then Y will be there, and vice versa, if Y is there, then X will be there. So these are certain basic laws. Now we shall solve certain examples, important examples. So our first exam question is, there are three sets A, B and C, and such that A intersection B is equal to A union C and A intersection B is equal to A intersection C. Then we have to show that B is equal to C. Now we have A union B is equal to A union C. So in this, taking intersection with B both sides, here it is B, we shall take intersection on both sides with B. Now A union B intersection B will be B. Why? Because A union B will contain elements either of A or B, and if you take intersection with B, then that means common elements, means elements of both which are present in A union B as well as in B. So that will be the elements of B actually. So it is B, and we wrote it here applying distributive law here, A intersection B union C intersection B. This is first. Now again we take A union B is equal to A union C. Now in this case we shall take intersection with C. In first case we have taken with B, now we shall take with C, and after applying distributive law in LHS this will become like this, and RHS will be C as same as it was in first case. So C is equal to A intersection C, B intersection C. We can replace A intersection C by A intersection B, because it is given here A intersection B is equal to A intersection C. So we can write here A intersection B in place of A intersection C. Now from this is our part 2. Now from first and second we can write B is equal to C. So it is proved now B is equal to C. Let's check another example. Show that A union B is equal to A intersection B implies A is equal to B. A union B is equal to A intersection B. So let X belongs to A. This will imply X belongs to A union B. Why? Because if X belongs to A, then certainly X will be the element of A union B, because A union B is the collection of all elements of A or B, means all the elements of A will be present in A union B. So X will be there. Now this implies X belongs to A intersection B. Why? Because it is given A union B is equal to A intersection B. So we can write A intersection B in place of A union B. Now this implies X belongs to B. Why? Why so? Because X is element of A intersection B, means common elements of A and B. Then definitely X belongs to B. Now conversely we take, now X belongs to A implies X belongs to B. It means A is subset of B. Simply, if X belongs to A implies X belongs to B. This is implying, it means A is subset of B. This happens only when A is subset of B. Now conversely we shall take Y belongs to B. Then Y belongs to A union B. Same tactics will be used here. Y belongs to A intersection B. Why is it so? Because A union B is equal to A intersection B. Okay. Now Y belongs to B implies Y belongs to A. This implies B is subset of A. This is case 2. Now from first and second you can observe that A is subset of B, and in second step we are proving that B is subset of A. It is possible only if both the sets are equal, means if A is subset of B and B is subset of A, it happens only when these two sets are equal. Now children, move to another aspect, that is difference of sets. What is difference of sets? Children, difference of set means those elements of A, means if there is A minus B, then difference of set means those elements of A which are not present in B. Means if A is subset of B, if A is subset of B, then A minus B will be phi, because all the elements of A are contained in B. So there will be no element which satisfies this property, that elements of A which are not present in B. So it will be phi. Now mathematically we can express that A minus B is equal to X belongs to A but not B. Let's have an example. A is equal to 1 2 3 4 5, B is equal to 1 2 3, A minus B is equal to 4 comma 5 here. So this is the difference of sets. Now children, move to complement of a set. Complement of a set, it is denoted by A dash, and it means all the elements of universal set except A. Means if we exclude elements of A from universal set, then that will represent A dash. Mathematically we can write it as x belongs to A and x does not belong to A. Let's have an example. U is equal to 1, 2, 3, 4, 5, 6 up to 10, and A is equal to 1, 2, 3. A dash is equal to U minus A. So elements which are excluding A means excluding 1, 2, 3. So we get 4, 5, 6, 7, 8, 9, 10. Now some basic properties. Complement of universal set is phi. Complement of phi is universal set. Complement of the complement A set itself, and union of set and its complement will be universal set. Union of a set and its complement will be empty set. There are certain properties, so you have to memorize all these properties. Now we shall move to De Morgan's law. Children, De Morgan's law is A union B complement is equal to A dash intersection B dash. Simply, if it is union, then there will be intersection. Okay, here it is the intersection, this will be union here. So this is De Morgan's law. Now children, let's have an example. This is a question of verification. Here universal set is given 1, 2, 3, 4, 5, 6, 7, 8, 9. A is equal to 2, 4, 6, 8. B is equal to 2, 3, 5, 7. Verify that A union B dash is equal to A dash intersection B dash. And part 2, A intersection B dash is equal to A dash union B dash. All these are De Morgan laws. Simply we shall first find A union B is equal to so and so. After that, A union B complement is equal to U minus A union B. This is equal to 1 comma 9, and A dash is equal to U minus A, and it will be 1, 3, 5, 7, 9, and B dash is equal to U minus B. It will be 1 comma 4 comma 6 comma 8 comma 9, and after finding A dash intersection B dash, it will be 1 comma 9. So it is verified from first part that A union complement is equal to A dash intersection B dash. This is the first result. Similarly, we can prove for second result. So you try to add yourself. Now children, let's take another example. So that if A is subset of B, then C minus B is subset of C minus A. So solve it. Let X belongs to C minus B. What it means C minus B? This is the difference of set. It means X belongs to A, C, but X does not belong to B. This implies X belongs to C, but X does not belong to A. Why? Because it is given that A is subset of B. If X does not belong to B, then there is no case that it will belong to A, because A is contained in B. This implies X belongs to C minus A. So what have we done? We took X belongs to C minus B, and we got X belongs to C minus A. That means C minus B is subset of C minus. As I told you children, if X belongs to A implies X belongs to B, then it implies A is subset of B. Okay. Now children, one question is for you to solve it at your own level and post it write it in comment box. Question for students: if L is equal to 1, 2, 3, 4, M is equal to 3, 4, 5, 6, and N is equal to 1, 3, 5, then verify that L minus M intersection N is equal to M minus M intersection L minus N. I think you found this video useful, and you will try to solve more and more questions from your textbook and from other reference books. And if you feel any kind of problem, then you simply write it in comment box so that I could resolve your problem. Thank you for watching this video.